Hello, and welcome to this tutorial on creating water towers and tanks for 3D printing using free software I call generators. The goal of this tutorial is to introduce you to the capabilities of this generator and to explain the function of the various options. Just as a reminder, my generators are available for downloading at my website, http://daakm.github.io. Right below my introduction there is a table of contents, and in the entry on Automating CAD is a link to download a zip file containing all the executable files. Before discussing the generator, we need to make a few assumptions. We will assume that you have successfully downloaded the generator's zip file, extracted them, and launched the water tank's generator. We will also assume you have learned how to post-process the SCAD files through the Open SCAD program to create stereo lithography files. If either of these assumptions is not correct, please watch the tutorial on creating a basic building where these concepts are introduced. As a reminder, the default values of all parameters represent good starting values, and if you are new to a generator, I recommend starting out just by clicking on the green Generate button to see how things work. The green button will ask you for a location to store the SCAD file, which contains 3D instructions to create your desired object. And to terminate the generator, just click on the red Exit button. The maroon and blue buttons load and save the configuration parameters respectively, and the orange button restores the default values. This generator is a bit different than others. Most others create one part type with options to configure it to your desires. This generator creates 7 different part types, but several are quite similar. There are 2 types of cylinders, 2 types of toppers, 2 types of leg sets, and a catwalk, so things are not as complicated as they seem. However, there are a lot of options, but to keep things simple, only the options which apply to the object you want to create will be displayed at any one time. There is no ladder. That might come in the future, but for now we call this a yo-yo. You're on your own. Every time you create a tank, the Notes window will tell you some facts about its capacity. In imperial units, a cubic foot of water weighs about 62.4 pounds and contains about 7.48 gallons of water at standard temperature and pressure. But in HO scale, a cubic foot translates into 42.88 cubic millimeters. So even a fairly large tank, 105 millimeters in diameter, 30 feet, and 35 millimeters tall, 10 feet, is only about 286,000 cubic millimeters and would contain about 50,000 gallons. Hemispherical toppers or bottomers will add some more capacity. Let's start with the simplest object, a metal cylinder or tank. We only have 3 options: a tank diameter, the thickness of the tank walls, and a tank height. The wooden tank is a bit more complicated, as these things were made of boards or staves, which expanded when wet and when compressed with metal bands made a suitable watertight vessel. Here we have options for the number of staves, the number of bands, and the height and thickness of each band. The generator will space the bands evenly from top to bottom. Next, let's look at the hemispherical top. The most important parameter is for the height of the dome. If this parameter is exactly 1/2 of the diameter of the tank itself, it will look like a hemisphere. Mathematically interesting, but not so much visually. I like to make the height somewhat less for a squashed look. You can make it more than half, but that would just look strange. There are also 3 checkboxes. The first will let you create a solid floor at the bottom of the dome. It might be useful if you want to do away with the legs and just have the tank sitting on the ground. The second is an option for controlling the tongue, a small cylinder which inserts inside the tank to provide a gluing surface, which you might want to suppress for some purpose other than the top of a tank. Lastly, you can request a hole to be placed in the top of the dome to allow you to insert a 3mm LED, which is closer to 3.3 millimeters by my measurements. The cone top is almost identical to the dome top, except it always has a floor, so there is no option to add one. But it adds a parameter for a cone overlap, which looks like the overlap extending over the walls of a house, but you can set it to 0 to make the cone flush with the outside walls of the tank. Finally, you probably will want to reduce the height of the cone to about 20 to 25% of the tank diameter to avoid making the cone look like a carrot. The object with the most options is the leg set, but they all make sense when you think about them. There are only 3 main components: the vertical leg pieces, the horizontal compression arms which hold the legs in place, and the standpipe. In a real-world water tank, we would probably have tensioners, a ladder, and possibly footings for the legs, but I made some concessions and left these off for now. From top to bottom, you can specify the number of legs you want holding up your tank, between 3 and 12, how tall you want them to be, and their radius. The bigger the capacity of your tank, the more legs would be demanded by your city engineer, and maybe larger ones too. The next 2 fields specify how far apart the legs should be in a circle at the bottom and the top of the tower. The top leg diameter must be smaller than the diameter of the tank they support. The bottom legs may be the same size of the tank or larger to make them appear at an angle. Moving on down, the next 4 fields refer to the horizontal compression arms, specifically the number of levels and their radius. I also included checkboxes to suppress the upper and lower set of arms. I hope one day to add footings to the leg set, in which case I would want to suppress the lower arms. There may be an obscure case when you want to suppress the upper set, so I included an option to do so, which you will probably never use. And at the bottom we have controls for the size of the standpipe. If you intend to run wires up the center for an LED, don't make the wall thickness too large. When I print this tower, I use supports. Nothing fancy, just normal supports, although I am considering moving to the tree type. Removing the supports may take as much as 15 minutes and can be a bit scary, wondering what, if anything, will break. Take your time, but it is easier than you think. I like to start at the bottom and work my way up, pushing the supports from the inside outward. For now, let's skip the catwalk and move over to the rooftop platform. These tanks were intended to be on the roof of a building to increase water pressure, back in the day when municipal water systems could not pump much higher than 3 floors, and building owners often had supplemental tanks and pumping facilities about every 30 feet of elevation, with all but the uppermost tank hidden from view. Let's start down the leftmost column and then proceed through the columns on the right and discuss the options. We begin with the platform size, which represents a square and must be larger than the diameter of the tank it is to support, probably at least 10 millimeters larger in HO. Then comes the platform thickness. These platforms were often large, joist-like pieces of lumber which stood on edge. To make the platform resemble planks, you can enter your desired number, and the generator will place bevels across the platform to subdivide it into joists. The last parameter in the platform set specifies how high to elevate the bottom of the platform above the roof. The bottom two fields in this column have to do with the supports which sit on the roof, which spread the weight of the tank and water over a larger area of the roof than would be the case with the legs alone. The supports will cover the same footprint as the platform, leaving an empty area in the middle. You get to specify their width and height. The middle column has some miscellaneous inputs, starting with the parameter which specifies the depth of an inset for the tank, a small depression which makes it easier to center the tank on the platform. Next, we have the leg diameter and another control to alter the angle of the legs from vertical. Don't try to make this larger than 15 degrees, if slanted at all. At the bottom of this column is a control that moves the base of the legs in from the corners. You will probably never use this control, but I wanted it, so I made it happen. At the right, we have parameters to alter the size of the stand pipe. When I print this platform, I use slicer-generated supports. My bamboo slicer has a tree support option which I highly recommend. It looks something like the enchanted forest from The Wizard of Oz when it comes off the printer, but it works really well and comes off easily. Now back to the catwalk. The catwalk has 5 main components: the rings around the tank, the rays which join the rings together, the uprights, their safety rails, and a larger ring at the outside which joins the floor to the uprights. Going down the left column from the top, we have a parameter which controls the number of rays that join the catwalk circles, or radials. The inner radius of the catwalk is sized based on the outer diameter of the tank, and the rays go through from the center to the outside catwalk circle. By default, there are 72 rays, one every 5 degrees. Next, we have a control for the thickness of the rays and radials, top to bottom and left to right. Smaller catwalks can have a lighter weight thickness, but I would not go below 0.8 millimeters. The radial count represents the number of circles in the catwalk, and the separation is the distance between the rings, center to center. On the right column, the top field contains the number of uprights, and the field below controls their height. The third field controls the number of safety railings between the catwalk floor and the top of the uprights. The fourth field controls the diameter of these rails. The bottom field in this column has a special purpose. The catwalk is somewhat fragile, especially at the joint between the floor and the uprights. To reinforce this joint, the outer ring is oversized to the size specified in the footing size parameter. You probably will not want to alter this parameter, but if you think it looks too heavy, you are free to reduce this field's value. Just don't say I didn't warn you. For its delicate nature, the catwalk prints surprisingly well on my bamboo P1S. I print it flat on the build plate with no supports. When printing the rooftop tank, I print the platform, cone, and tank separately and glue them together. I usually print the tank and cone without supports and suppress the tongue on the cone to achieve a perfectly flat bottom surface. I then center the cone manually on top of the tank and glue. When printing the municipal storage tank, I first join the dome or cone and the tank together in Tinkercad prior to exporting and printing. To do this, I import the two pieces and note the height of the tank. I then raise the dome or cone just about, but not quite, to the top of the tank. I want it a bit short to take into account the height of the tongue, which is not under your control, but is 4 millimeters. Thus, if the tank height was 50 millimeters and the tongue height was 4 millimeters, raise the dome or cone 46 millimeters and center the dome or cone to the tank. I probably will alter the snap grid resolution to 0.10 millimeters and fine-tune the elevation of the topper. Finally, I group them prior to exporting and printing. Depending on whether this is a contest piece, I may print it at a layer height of 0.08 millimeters or 0.20 millimeters. I specify slim tree supports in the slicer. Similarly, I import the leg set and a second copy of the dome into Tinkercad and flip the dome upside down. I then raise the dome as high as I want, almost to the top of the leg set. I then center the leg set and the inverted dome in both the X and Y direction and group the pieces. I then flip the entire assembly upside down with the face of the dome on the build plate. I export the composite and print. By doing it this way, I don't have to worry about drilling holes into the lower dome. Tinkercad hides them for me inside the lower dome, and the lower dome holds the standpipe as well. I print the catwalk separately. When all parts are printed, I add a decal if desired, and place the catwalk around the bottom of the tank, perhaps elevated a few millimeters, and glue the upper dome and tank to the lower dome and leg set, and finally slide the catwalk down to the lower joint and glue it to the tank. That's about it. I hope you found this video informative and will give this generator a try. Thanks for staying in touch.